Welcome back, learners. So as we have said, we're going to be looking at our application questions, and they are still based on the reaction between an acid metal oxide or an acid and a non-metal oxide. So let's start. We have that. Our first question says, how can a metal oxide be formed in general? So how do we generally form our metal oxide? We do know that for us to have this metal oxide, a metal needs to react with oxygen. So a metal needs to react with oxygen so that we can produce our metal oxide. Our metal oxide. Now, second question says now, give an example of a metal oxide of a group 2 element. So remember, in our periodic table, we have group 1 all the way to group 18. If you count them going down vertically, we have group 1, those ones are called the alkali metals, and then group 2, alkali earth metals. So those ones are the common metals that you're going to be using throughout this lesson. So we can find our metals on the periodic table, on the left-hand side of the periodic table, and then on the far right-hand side, we can find our non-metals. Then in between, they make a zigzag starting from boron going down, making a zigzag. So those ones, they are called our metalloids. So they're semi-metals. They have properties of both the metals and the non-metals. They are in between. So now when talking about the metal oxide of a group 2 element, that means we need to use a metal that is found in group 2. So in group 2, we can find, for instance, magnesium. So our magnesium is a metal found in group 2, and then when it reacts with oxygen, is going to form our magnesium oxide. And we do know that the metal oxides, they are basic, and then the non-metal oxides, they are going to be acidic when they are dissolved in water. So how can a non-metal oxide be formed in general? So if a metal plus oxygen reacts to form metal oxide, then a non-metal reacting with oxygen is going to give us the non-metal oxide. Then we need to give an example of a non-metal oxide of a group 16 elements. So as you have said, we have 18 groups in the periodic table, vertically from 1, 2, 3, all the way to group 18, the last one, known as the noble gases, because they are less reactive, they are unreactive. So the elements in group 16, we can look at sulfur. Sulfur is an element found in group 16. So it forming a non-metal oxide, it is going to be our SO2. So now, we also know that the metals, when they are reacting with oxygen, they have a general formula that is going to be MO, M for metal. And then now our non-metal oxide, when they are reacting with oxygen, their formula is going to be MO2, the general formula of the metals and the non-metals oxide when they are reacting with oxygen. So we have our metal and our oxygen there as our part of the reactants to form our non-metal oxide. So our next question is asking us questions that are based on the sulfurous acid. So what are they asking? So they're asking that, so we're given firstly that diluted sulfurous acid, which has a chemical formula H2SO3, splashes onto zinc roof sheeting. Where the acid lands, the zinc turns from silvery gray to dark gray. So where the acid lands, the zinc there will turn from silver to gray or to dark gray. So question is, what is the sulfurous acid dissolved in? So that diluted sulfurous acid, what is it dissolved in for it to be diluted? It is dissolved in water. So it is dissolved in water. Then question B says, give the everyday term for this solution. So the solution that you're talking about here is the acid rain. Because once that sulfurous acid, as it lands onto the zinc, so it lands in a form of rain, and then that rain is going to turn the zinc from silver to dark gray. So this is going to be your acid rain. Then question C says, what general equation do we use to describe the reaction between the acid and the zinc? So let's just think about it for a minute. We have acid, could be any acid, plus zinc, and then the product that is going to be formed here, it is going to be our zinc chloride, which is going to be our salt plus hydrogen gas. And you may be wondering and asking yourself, why do we now have hydrogen gas? What happened to the water? So to better explain this, let's make a use of a practical example of the acid. So let's use HCl as our hydrochloric acid plus zinc, and we are saying that the salt produced is going to be our zinc chloride plus H2 gas. So now, let's check. We are saying that the acid always has a hydrogen to donate or to contribute into the reaction. And then the base must have the OH to contribute into the reaction. But then when looking at this reaction, we are not looking at the metal oxide or the non-metal oxide. We are looking at the reaction between an acid and a metal. So this is your acid plus a metal. It's not a metal oxide or a non-metal oxide, it's just a metal. So this zinc or this metal doesn't have any oxygen or any hydroxide to contribute into the reaction. So which is why the acid will only be contributing the hydrogen. So that hydrogen is going to be donated and is going to come out as a hydrogen gas, not water, because we don't have any oxygen within this reaction. Right? So therefore, the acid is going to donate the hydrogen, and then the remainder of whatever that is left after the donation or after the contribution of the hydrogen is going to be our salt. Hence, we have now our chlorine reacting with the zinc to form our salt, being the zinc chloride. And then the hydrogen, because it doesn't have any O or any OH to chemically bond with to form water, it will just be our hydrogen gas there. And as you can see, our reaction is not balanced, but then to better explain what you're talking about here, the acid will donate only the hydrogen because all acids have hydrogen, but then not all bases have the OH. Some have just the H to donate or to contribute into the reaction. Or some have the O to contribute into the reaction. So when the H is donated or contributed by the acid, chemically bonded with the OH, or the O from the metal oxide or the non-metal oxide, the water will then be produced. In this case, we are not looking at the metal oxide or the non-metal oxide, so we don't have the oxide. That is why our product will just be the hydrogen gas from the acid that you started with. Right. Next question now. So still on the diluted sulfurous acid, now we are asked to write a balanced chemical equation for this reaction if one of the products is zinc sulfide. So we are told that we have the diluted sulfurous acid that splashes onto zinc roof sheeting, and then therefore the product that is going to be formed there is going to be zinc sulfide, one of the products. So the reaction is, in terms of the chemical equation, we are going to have our H2SO3 plus zinc. This is going to react to form one of the products, and that is going to be our zinc sulfide, ZnSO3 plus. So now we need to check if on the reactant side we had zinc and on the products also have zinc, and then we have the sulfide on the reactant side and we still have the sulfide on the product side. What is missing is our hydrogen, our H2, as a diatomic molecule. So remember, the type of atoms that we start with at the beginning of the reaction should be the same type of atoms that we end up with at the end of the reaction. So now we cannot just have oxygen there in place of our hydrogen, because we didn't have O2 to begin with. That oxygen was attached to the sulfur to make our sulfide. So now we always need to make sure that what we start with, we end with. Now, the most important thing that we need to do right now is to balance the chemical equation. So for us to do that, we need to check the number of atoms on either side, that they are equal. When looking at the reactant side, we can see that our hydrogens, we have 2 of them, that's subscript 2. Then also on our products, we still have 2 hydrogen atoms. Then our sulfur on the reactants, there's 1 products, 1 sulfur. Then on the reactants, we have 3 oxygen because of that subscript 3. And then we also still have 3 oxygens because of that subscript 3 on the products. And then lastly, we have 1 zinc on the left-hand side being the reactants. And then lastly, we have also zinc, 1 zinc atom on the product side. So that means everything checks out, everything balances out. The number of atoms on the left-hand side are still equals to the number of atoms on the right-hand side. So therefore, this equation is balanced. There we go. So, before we move on to the next part of our lesson, we're just going to quickly go for a short break, and I'll see you just after this.